Hey everyone, I am Zia, working as a data scientist for over 8 years. And if you are a data lover, then this tutorial is surely for you. Because here we are going to see how we can measure the newsroom drift by using massive proxies. Well, that's just one title that can cover whole lot of different use cases. For example, if there is some data available anywhere, for example, at any e-commerce website, in any news website, at any blogging website, and you want to see how this whole drift is working with the passage of time, how many headlines are being changed, how pricing is being changed, how data labeling is being changed at a particular URL, we are going to explain that to you. But there is one problem. If you want to know the difference over time for a particular website, you have to keep hitting the URL of that website for a lot of times. Well, if you're going to do that and you're going to write code for it, your IP is surely going to get blocked. So massive proxies is providing us with a solution. You just sign up on joinmassive.com and you'll find great proxies over there that I'm going to use over here in today's tutorial as well. So if you will use these proxies, your IP will be saved. And basically, you will be using massive proxies IPs that will be rotating your IP over the time. And there won't be one IP that will be hitting your request to the target website. So if even one IP will be blocked, massive proxies will provide you some other IP, and so on and so forth. So ultimately, your whole flow will be seamless, and we will be able to fetch the drift on right now in this tutorial, the drift on the news website, but you can also modify it as your need in order to find the drift on e-learning website as well. So let's get started. I'm going to use massive proxies by using Python, and we are going to build something cool in less than 15 minutes. Let's get started. So it is time for some practical work. So let's go ahead and scrap or not our website, but the BBC website, right? Again, we are importing some libraries. We are using TQDM for the progress bar, beautiful soup for parsing. We are using this sequence matcher in order to find the differences in the headlines, and then we are importing request time and date and pandas as well for data processing. The URL we're going to use is the BBC. We're going to fetch the top 20 news. The interval is going to be 600 seconds. This is important. You can change it you can update it according to your need. Right now, it is going to hit the URL after every 10 minutes. 600 seconds means 10 minutes, right? But if you want to hit the URL after every 1 second, you can replace the 600 with 1. Or if you want to hit the URL after every 1 hour, you can write 60 into 60, I don't know, maybe 3600 over here. This is, remember, this is in seconds. I've mentioned it in the comments as well. This is in the seconds. Then maximum we want to have 11 rounds, which means that 11 times I want to scrap this website. You can update it to 1100 as well if needed. If I run it 11 times, it means it will take roughly 1 hour and 60 minutes for me, right? As you can see, it is already running. So I had already run it, so that maybe after the end of our talk, it might be completed. If not, I have already prepared the results. No worries. And then we are setting up the proxy. We are saying if we want to use the proxy or not. Yes, we want to use it later on. If you see where we are building the proxy, we are checking if we want to use the proxy or not. So if we don't want to use the proxy, we are returning none. Otherwise, if we want to use the proxy, we are returning the proxy object. That includes proxy user, proxy path, the host, and port, right? So the whole object will be returned. Very simple. These just a few lines of code will set up the whole proxy for you. And I mean, that's an automated process that will keep hitting the website for as many times as you want, and your IP will not be blocked. Join massive will be responsible for this whole process, right? Moving on. So here we are building the proxy, and then we are simply checking if our proxy is working or not. If it is working, it will say proxy connected. If it is not working, it will say proxy check failed. Cool. Moving on. So first of all, actually, let's move on towards the final code and then we'll track back. That will be easier for us. Okay. As you see, it says proxy is connected to US. So right now we are using the US proxy, although I'm not sitting in the US, but it is using the US proxy. And it is the progress is 55% done. Fine, let's see. Okay, so from here, our main loop starts. As you can see, the main loop. So first of all, what is going to happen over here? So we are saying iterate for how many times? For maximum number of rounds. That was 11, if you remember. And first of all, in the data frame, df, we are fetching the snapshot. So what is happening over here? We are simply hitting the news URL, which was the BBC, if you remember, setting the headers, setting the proxy, setting the timeout, and then we are requesting to get the object. So once we get the object, then we are saying extract the headlines. How many? Top n. If you remember, we had a variable that was probably 10 or maybe 20. I don't remember. So we are extracting the headlines. So here the extraction procedure is happening. We are simply using the selectors in order to select the titles of the news. Right? Simply, if you go to the website, you right click, you go to inspect, we will be able to see the whole object, and I mean, by using the selectors, we can fetch any headline from there, right? And then we are putting all those top n URLs in a data frame with a title and its URL in a data frame, right? And then let's go to the main code again. After, where's the main code? Oh, let's drag it. Okay. So yeah, so first of all, what was happening? So we were fetching the snapshot, and then we are appending that snapshot in a list called snapshots that we have created. We need all the snapshots, we need all the URLs over the time. Snapshot means at a particular timestamp how that whole thing, that whole page was looking, right? How many URLs were there, which URLs were there, which news were operated over there. So everything will be there in the snapshot. So for after every, in my case, after every 10 minutes, I will have one snapshot, and ultimately I will have 11 snapshots. And then I'm checking if I have at least one snapshot. Then I want to calculate the difference between all the snapshots, between the previous and the current snapshot. Why this check? Because if I'm iterating it for the first time, I have only one snapshot, then there's no way I can find the difference. You cannot find the difference of one thing. You at least have to have two things. So if you will have at least two things, so you will be sorry, here we'll be finding the difference of current snapshot versus the previous snapshot, right? So we are saying difference with details. Let's go. Okay. So here we are actually merging the old snapshot and the new snapshot by using the outer merge. Outer merge, again, it gets us, so if we are merging it on the outer basis, then what will we get? If we check the left only, we will get how many or which URLs were removed from the, as compared to the previous snapshot. And if we get the right only, we will get the ones that are added. So which ones are removed, which ones are the added, we can easily detect that. And then if we calculate their difference, we will find out which ones are modified as well, right? I mean, it is quite possible that previously there was some title which is modified now, so we can easily detect that as well. So ultimately, we have the added data frame, removed data frame, modified data frame, which will be returned from here along with this whole matrices, which is calculating the drift based upon the percentage and everything, right? And then after calculating all these things, then we are simply changing the interval of all of this whole process. And finally, here we are calculating the drift summary by using this method. Here it is. So this method is responsible for calculating the drift summary for all the headlines. It takes the interval changes, snapshot, and examples per, and then it simply, by using easy mathematical calculations, it calculates our summary, which is also explained in our article as well. So until here, we will have, since this is still running, so let's go to the one which I have already run. So until here, we will have this kind of a table. Let me zoom out a little bit. Yeah. Okay. So for example, at time interval 1, which was this timestamp, right? That started from this, ended at this. There were 2 new titles that were added that are listed here. And then there were 2 titles that were removed, which are listed over here. So overall, the percentage of drift was 20%. So the observation is 2 are added, 2 are removed. Moving on, if we look over here at interval number 5, that starts from this time, ended at this time, 1 more headline is added, which is this one. 1 is removed, which is this one. So overall summary, overall here, if you see, we have 1 title which is modified as well, which was there. The URL kept same, remained same, but the title was slightly modified due to, I don't know which reasons. So there is 15% of the drift, 1 added, 1 removed, and 1 modified, right? And in the iteration or interval number 6, we can see there is absolutely no difference. So in this particular time, nothing was added, nothing was removed. And if you pay close attention, you see it is starting from 20 hours and 1 minute and ending at 20 hour 31 minute, which means that when I ran this particular iteration or this particular code, the time difference was 30 minutes. So this was ran with the time difference of 30 minutes, but the current code is running with a time difference of 10 minutes. So until here, we will get the summary, and guess what? If we have a data frame, the beautiful data frame like this, a data analyst or a data scientist will always be tempted to create some realizations. So I created some realizations like this, where I'll show you how, but let me just zoom out. Okay. So first of all, we have the headline drift over the time. You can see at this particular time, 21:18 minutes. It was here at 21:18 minutes, 30 seconds. It was here, and so on and so forth. You see, it is moving, right? And by the way, this 21 is the date, not hours. So it is 18 hours 30 minutes. Sorry, overall 18 hours 00, and then 18 hours 30 minutes, then 19 hours, then 19 hours 30 minutes, and so on and so forth. Moving on, we have this grouped variant, the grouped bar chart variant that shows over the time how many were removed, how many were added, how many were modified. Very, very easy to understand. Then overall cumulative headline drift, this is how we can see that. How to create that? That might be a question in your mind. Good question. So very simple. Once we have this data frame, we will convert it. We already have it in a data frame format, so we don't have to convert it. If we want to export it as a CSV file, we can do that. Otherwise, we are importing matplotlib and numpy over here so that we can perform some data visualization. And here we are creating a line plot that you watched at the very first time. So we are simply creating this plot by adding this timestamp at x-axis, the percentage drift at y-axis, and marker was 0, or the circular marker as you have seen over here. This one, right? The marker. You can also have a cross marker as well if you need it. So we are adding some labels. We have added a title, and we are adding a grid, and finally we are showing it as well. We are also exporting it as well. The second graph, the grouped bar chart that we saw over here, this one, again, we are using matplotlib. So we are saying that the first bar is going to be this one, which is for the added count. Second bar is this one, which is for the removed one. And third one is going to be the modified one, right? So you can see 3 bars over here. You might say that for the first few, we cannot see the blue bar. Why? Because it is at 0. The modified variable was 0 for first 3 bars. That's why you can't see it over there, right? And then finally, for cumulative, again, it's a line chart, so it is very much similar to the first one. We are plotting it by having the cumulative drift at y-axis, and then we are adding titles, labels, and finally we are showing it and saving it as well. The details are mentioned in the article as well. The charts, the table, everything is explained in the article as well, and the whole theory behind it, how it works, everything is there again in the article. You can find it in the description, and that's about it. Thank you very much.